Electrical components and equipment. Maintenance of marine electric motors. The maintenance requirements for cage rotor induction motors are very simple. Contact resistance low, keep insulation resistance high and lubricate correctly and maintain a uniform air gap. Ensure both the interior and exterior are always clean and dry. Provided these requirements are met, an induction motor should give trouble-free service during its long life. The most common cause of induction motor failure is failure of stator insulation due to dampness is a major problem with marine motors. Open ventilated motors are most at risk, particularly when they are not used for long periods. Anti-condensation heaters should be regularly checked to see that they are actually working and keeping the motor dry. For all motors, cleanliness is next to godliness. A regular cleaning routine is required to remove harmful deposits of dust, dirt, grease and oil from both inside and outside the motor. The cleaning of the external surface is especially important for totally enclosed motors which run continuously. The heat generated in these motors is removed through the external surface. A thick layer of dust will reduce the heat dissipation and result in very high temperatures. Internal dust and dirt in open ventilated motors must be regularly removed by blowing or extraction and ventilation screens and ducts cleared out. If motors are to be blown out, the air used must be absolutely dry and the pressure should not be more than 1.75 bars. If the pressure is higher than this, it forces the dust into the winding insulation rather than removing it. When blowing out a motor, remember to cover up other machines in the area to protect them from flying dust. Suction cleaning is better than blowing out. How often should a marine motor be cleaned? Basically, this will be determined by the local conditions and the type of ventilation. Only the external surfaces of totally enclosed motors will require regular cleaning. But both the outside and inside of open ventilated motors will require routine attention. The inside of a totally enclosed motor can be cleaned if the motor has been dismantled for bearing replacement. Motors in areas where considerable amounts of airborne dust are expected, hatch cover motors are an example, will obviously require more frequent cleaning. Contamination by oil and grease from motor bearings is often a cause of insulation failure. The insulation should be cleaned by brushing or spraying with one of the many proprietary brands of cleaning fluid which are available. Badly contaminated motors may require total immersion of the stator windings in cleaning fluid. Broken or missing bearing covers must be repaired or replaced to prevent grease escaping. When a motor has been dismantled for cleaning and overhaul, it should be thoroughly inspected. In this way, faults can be detected before they evolve into a major breakdown. Main switchboard or MSB to be installed on a raised platform. The location where switchboard or MSB is installed should have good ventilation, illumination and affected by minimum vibration. No water or oil pipes should pass above the switchboard or MSB. There should be adequate space around allowing comfortable operation and maintenance. The operating floor space in front and behind the switchboard or MSB should be covered with anti-skid, insulated rubber mats with a minimum thickness of 15 mm. Panel doors should be in locked position. Door opening mechanism should be interlocked with power supply. The enclosure should be drip-proof. MSB should be dead front type, i.e. all the live conductor should pass behind MSB. Every equipment on board must be properly earthed. Also, MSB must be properly earthed. Every incoming and outgoing feed must be protected by a switch, fuse or circuit breaker. Insulation resistance should not be less than 1 megaohm in any condition. All meters must be calibrated periodically and records are maintained. All the meters, switches, fuses, push button, indicating lamps, etc. should be in working condition and identified with individual name plate or tag. All the interlocks must be in working condition. Operating switch gear, tools such as circuit breaker handle, fuse puller, lamp grip, etc. must be readily available and to be used. Red tag, name plate indicating high voltage and danger sign should be fitted. Appropriate ready-to-use fire extinguishers should be positioned nearby. CO2 and DCP. Charts indicating drill procedures in case of electric shocks must be displayed near MSB. Wiring diagram laminated or framed indicating supply system must be displayed nearby.